Hi everyone. Sorry for the delay. So let's go straight into skills practice 1.3. The most important thing about this is that we remember what is the domain, codomain, object, and image. Okay, so right now we're going to deal more with the object and image. So as we mentioned before, a function is an equation that relates an object to an image. So how does the object become an image? So like in the example that we saw the other day, say for example this lah kan. So the function, this is the function. Okay. So half of, and then the object is 2, and then becomes 1. So half of 2 becomes 1 is what we were talking about the other day. Half of 2 is 1. So in that sense, this half of, okay, is the function. Okay, and 2 is the object, and therefore 1 over here is the image. Okay, so we can conclude that if let's say I were to write it in our, either the obnoxious way or the normal way, okay, so half, okay, of the object, I'm going to call the object X, okay, half of the object, okay, equals to the image, okay, and usually we will call the image Y lah, okay, but we're going to replace the Y because the other day we talked about writing it, this one right there, express H in terms of X, okay, and we said that the image, we're going to call it HX, like a combination of the function and the object becomes the image. Okay, so in the example just now, since half of the object is this one, so I'm going to call this as fx. Okay, let's say I call the function f lah. The function of an object equals to the image. So our function will be half x, like that. Okay, so what is important to remember about any function is that whatever that is in this bracket here is the object. And in order to find the real image, you have to substitute the object into the function. Let me repeat. In order to find the actual image or the value of the image, you have to substitute the object into the function itself. Okay, so let's take a look at this example first that we are now looking at. Okay, so function g is given as, blah, blah, blah over here lah. Okay, so in this particular case, I'm going to rewrite this as gx, okay, equals to 3 plus 6 over x minus 1. Take note that the x over here and the x over here, this one. The function is gx, okay, the function is 3 plus 6 over x minus 1. X is the object. So now we want to find the image, okay, which is the first question. Find the images of -5, -2, and half. So this question is telling you that this -5, all these are objects. Okay, each one is an individual object. Okay, so -5 is an object, -2 is an object, half is an object. So if we were to map this out, okay, if we were to map this out, let me put all the objects here like -5, -2, and half. Okay. And so our function over here is 3 minus 6 over x, 3 plus, okay. Our function is 3 plus 6 over x minus 1. That's our function. So we want to find what, after we map it with this function, we want to find what is this answer. So what do? We replace the number on the object into the function. So how we would write this would be f -5. Oh, sorry, is it g or f? Oh, sorry, it's g. G -5, okay, equals to 3 plus 6 over -5 minus 1. Okay, let me just change this to a different color so it's easier for you to see. G -5 and then the -5 over here. Notice that the red color, the function still remains. What I'm doing is just I'm replacing the object into the function. Okay, so then what we calculate is, we calculate this one. Okay, so when we calculate this one, we will get 3 plus, this will be negative 1. 3 plus negative 1 will give you 2. So our answer here will be 2. Okay, so the negative 5 will be mapped to 2. And then we do likewise lah for the other two. Okay, G negative 2. Okay, now our object is negative 2. Okay, our object is negative 2. So we put it into the same function as always. 3 plus 6 over negative 2 minus 1. Okay, all we're doing is just placing the object into the function to find the image, to find the end result. That's what we want to do. Okay, so this will give us an answer of 3 plus 6 over negative 3. This will be negative 2. Our answer here will be 1. So when we map the negative 2, we will get here, this will be 1. Okay, and finally, we will use half. So G. Okay, now my object has changed to half. Okay, so equals to 3 plus 6 over, and we put again the half. Half minus 1. Okay, so then we will get our final answer here. Okay, so I'm not going to show you the answer. I think you can calculate this yourself. But this is the basic idea of how to find an image if I give you an object. Okay, so you replace the object into the function to get the image. So these two, this one, and whatever this answer is, these are all the images. Like if we map it, this is what we will get according to this function. Okay, this function over here. Okay, so then they say given the image of B is 2B. Okay, so they're saying that if let's say, sorry, I make this one bigger. If let's say the image of B, it means the object is B, and then if I map it, it becomes 2B. Okay, so the question says find all the possible values of B. Okay, so let's go and try to do this. It's saying that if the object is B, okay, what I'm going to get is, let me replace it into the function. Okay, so 3 plus 6 over B minus 1. Okay, but it already gave you the final answer. It already gave you the mapping. They say the mapping is 2B. Okay, so 3 plus 6 over B minus 1 actually equals to 2B. Okay, that's what it's saying. So it's saying that this GB is actually equals to 2B. So because of that, we can erase this. Don't need to put this in actually, because we already understand that when we put the object in here, we will get this. Okay, and so this now becomes a matter of shifting things around. Okay, so first of all, let's bring the 3 over here. Okay, so 6 over B minus 1 equals to 2B minus 3. Okay, and then B minus 1, we bring above, we'll get 6 equals to 2B minus 3 times B minus 1. Okay, and this is precisely the reason why you learn all those Form 3 mathematics. That's very complicated one. Okay, so I'm going to multiply this. 2B times B will be 2B squared minus 2B minus 3B plus 3. Okay, equals to 6. Okay, and I think when you're in Form 3, you know that this is a quadratic equation, and you know that you have to factorize it. Okay, but before factorizing, move the 6 across. Okay, you're gonna get 2B, sorry, equals to 0. 2B squared minus, okay, I'm gonna settle this. Minus 2B minus 3B minus 5B. Okay, then plus 3 minus 6 will give you minus 3. Okay, and so when you factorize this, okay, you'll get 2B and B over here. This will be 3 and 1. I believe this will be both. Oh, no, cannot. This will be 1 and 3. Here 1, here 3. Okay, this will be minus, this will be plus. Okay, so then this one you will get B equals to negative half. Okay, and this B equals to 3. So both are possible values of B. Okay, now I know I'm kind of rushing into this because I'm assuming that you know how to do this already, since this is actually maths from 3. But if you are not sure about how to do this, then I would suggest that one, you can either come and ask me to show you exactly what I mean by this, all this factorizing and everything, okay, in case you've forgotten. Or number two, try and refresh it yourself. Okay, maybe you've learned this, but you've forgotten about it. Okay, I'm kind of rushing into this because these are things that you should already know coming into AdMaths. Okay, so if this is a bit of like complicated for you, it's okay because I'm going to do one video per question lah. Okay, so you can go to the next video if you're done with this question. If not, then I suggest that you watch this video again. All right. Okay, question number 2. Okay, function h is defined as such and such. Find the value of k such that h2 equals to 5. So once again, to remember, pink color is object, green color is image. Okay, what this means when we map it out, okay, is that 2 is to map to 5. This is what it means. Okay, and the function is kx minus 3 over x minus 1. Now, this is the function lah. Okay, so let's put it into proper words. We know that x is always the object. Okay, so and this time the object is 2. So h2 equals to 5. Okay, don't forget that our 2 is actually the object. Okay, and our function is kx minus 3 over x minus 1. Okay, so let's put the 2 into the x. So we will get k2 minus 3 over 2 minus 1 equals to 5. Okay, and I think from here you can actually find the k already lah. Okay, 2k minus 3 over 1 equals to 5. 1 times 5 will give you 5. So 2k minus 3 equals to 5. Move the 3 across. 2k equals to 8. K equals to 4. Okay, so this is not a difficult ask. It's quite simple. Okay, the second one is h3 equals to k, which means that if we map it, remember 3 will go to k under the same function. Okay, so h3 equals to k. Okay, so substitute the 3 inside. Okay, so k3 minus 3 over 3 minus 1. Okay, as long as the object is x or whatever letter is in the object, okay, we replace it with that number lah, equals to k. Okay, so you'll get 3k minus 3 equals to over 2 equals to k. Bring the 2 up. 3k minus 3 equals to 2k. 3k, I'm going to switch this around. So 3k minus 2k equals to 3. 3k minus 2k will give you k. K will be equal to 3. Okay. Okay, for question 2C, there is a mistake in the question, so we're not going to answer that question lah. Okay, so just take a look at these two. Again, if you have any questions, you can always ask me either in the group or DM me. But make sure you're done with this question, then move on to the next question. Okay, question number 3. So we have this function that once again has this modulus sign. Remember, modulus is more about the image. If the image is negative, nope, it becomes positive. If the image is positive, it remains positive. Okay, so the most basic one is we find the image first lah. F negative 2 and F negative half. Those negative 2 and negative half are objects. Okay, so we want to know, okay, if this is negative 2, negative half, after I map it out, okay, to this one, what is my image? So we replace the numbers into the function. So F negative 2 equals to 4 times negative 2 minus 3. We will modulus it. Okay, don't forget, this is the object that has to be put into this one. Asal X, X, asal Y, Y. Okay, so let's calculate this. This will give us negative 11 modulus. But because it's modulus, okay, so the answer will be 11 positive. Okay, this is what it means. The other one will be F negative half. Okay, so 4 times negative half minus 3. Okay, this will give you minus 2 minus 3, which after you modulus it, after you remove the modulus, becomes 5, like that. Okay, so just to remind you that when you throw away the modulus at the very end, okay, then you change the negative to positive. Okay, next, be the values of x such that fx is equals to 1. Okay, so now they give you the image. The image is 1. They're asking you, what is the value over here that will give you the number 1? Okay, so you have fx equals to modulus 4x minus 3. Now they tell you that the image is 1. Okay, the image is 1. So let me throw this away. 4x I'll throw since I already have the image. Okay, now when it comes to modulus, in normal maths, we just 4x minus 3 equals to 1. Then we move the 3 across. 4x equals to 1 plus 3. 4x equals to 4. So x equals to 1. So this is x equals to 1. So solving modulus equations is slightly different. Okay, if you have time, okay, go and scan this QR in your textbook over here. So they will tell you how to do this involving absolute values now. But basically, whenever you have a modular situation, you have to have two answers. Okay, so when you open the modulus, you will have to, okay, this is different now, this is something new. We have to have two different answers. So the two different answers, okay, one is obviously 1 lah, okay, as follow like this lah. But the other one will be negative 1. Okay, because you remember, if you modulus the 1, you get 1. But if you modulus the negative 1, it will give you also 1. So, our final answer is 1 can have actually a possibility of two different answers. Okay, so we can write over here lah. So 4x minus 3 equals to 1. The other one is 4x minus 3 can also equal to negative 1. And so because of that, we will get 4x equals to 4, x equals to 1, one answer. The other one is 4x equals to 2 and x equals to half. Okay, this will be our two answers for this question. Okay, so this is the first thing that we need to learn from this question. If there's a modulus, we have to split it up, okay, into two different answers. But now we come to another question, which is the domain of fx is less than 1. Okay, what is the domain? So if I put the fx, okay, so fx is less than 1, okay, so let's put in this one first lah. Okay, 4x minus 3, sorry, modulus 4x minus 3 is less than 1. Okay, so the long story is actually in this QR lah, which I actually recommend you to go and watch. Okay, but if you want a shorter version, take a look at this example. Okay, it has almost the same situation, except that when we open the modulus, we still have this concept of two answers, except that they're in one continuous inequality. Okay, so one will be negative, one will be positive on both sides. So what you can do is the 4x minus 3, you put in the center, and after that, less and less. And then since this is 1, so left side will be negative 1, right side will be 1. Okay, if this number is, let's say, 4 lah, okay, let's say contohnya lah, katakan fx minus 3 modulus is less than 4. So when you open the modulus, it become negative 4 less than 4x minus 3 less than 4. That's the idea behind this lah. Okay, so when you do this, okay, if you take a look at this is what's going to happen. So you do the equation on both sides. Okay, so the 3 you move to both sides over here. So you have 4x left, less than, okay, minus 1 plus 3 will be 2. And then over here, we minus 1 plus 3. Sorry, 1 plus 3 before, my goodness. Here will be 4, here will be 2. Okay, so, so then we transfer the 4 over to each side. Okay, this will be divide, 4x divide. Move the 4 across will be divide, so this will be 1. You're left with x, and then you're left with, this is half. Okay, so this is our final answer for the domain. Okay, so the answer is in an inequality, which is also something that you learn in Form 3 maths. Okay, finally, the domain of fx is more than 5. So notice the difference between question C and D. C is less and D is more. So even in the example here, if the answer is less, the final answer will look something like this. But if the question is more, then you have to do it like this. Okay, less than this one and more than that one. So let's go. So fx is more, okay, than 5 is our question. Okay, so let me put the modulus in. 4x minus 3 is more than 5. Now, so this is where it gets very tricky, which is why I actually recommend that you look at this QR because it actually does help. Okay, when we open the modulus, okay, it will be very fundamentally different from the one that we saw over here. Okay, because of this sign. This sign now is more. Okay, so when we open the modulus, it will become, okay, on the right-hand side, I'm going to leave the more than 5. This will be 4x minus 3. Okay, but on the flip side, because we know when we open a modulus, one will be positive, one will be negative. So this will be negative 5. But the symbol will change to less. Okay, so 4x minus 3 is less than negative 5. And then you solve like normally how you would solve. For x is more than 5 plus 3. So x is more than 2. And then this one will be 4x is less than negative 2. Okay, and you will get x is less than negative half. You will get 2 sets of answers. Okay, now I know that maybe for some of you this is very new, okay, especially with this modulus thing. What is actually new, okay, is this part. Okay, this part yang mau kasih buka itu modulus, that is actually the new thing in AdMaths. Okay, everything down here, okay, are things that you should have learned and remembered in Maths Form 3. Okay, now I'm not trying to discourage you or anything lah. Okay, but you know, coming into additional mathematics now, coming into AdMaths, you cannot leave your maths that you learned in Form 1 to Form 3 behind. You cannot. Because it's not maths, is not something that you can leave behind and you learn something new. You know? It's not like science or physics or even chemistry or biology. Maths is a totally different ball game. If you don't have a good foundation in your maths Form 1 to Form 3, then you will need to catch up if you really want to take AdMaths in Form 4. Okay, everybody says that AdMaths is difficult. Actually, what is difficult is when you don't remember or you don't keep practicing what you were doing in Form 3, in Form 2, in Form 1. In Form 1, Form 2, Form 3, if you were playing the fool and you were not really serious about your maths, okay, coming into AdMaths is going to be a challenge for you because you got to remember everything that you learned before. Okay, everything that you may have forgotten. Okay, so this is the important thing about maths. You cannot forget. After the exam is over, you cannot forget all these skills. You have to bring it with you because you're going to need it for the future. Okay, especially to take advanced. So again, this is not a word of discouragement, but I want to remind you that if you don't know this stuff, okay, all this basic stuff of pinda and how the positive become negative, this is the time for you to buck up, okay, and relearn all this. Sure, it's going to take some time for some of you, but you know what? You need to spend that time if you really want to succeed. Success is not going to come to you just like that. You have to work for it. Okay, and this is the question that you need to answer. Are you willing to work for your success? If you are, then you know what? I'm going to walk alongside you and make sure that you do the best that you can. But you need to want to have it. Okay? Okay, question 4. Given that, then you have this modulus again. Now we find this gx equals to x. Okay, so we're just going to do it normally. So gx equals to x. So since we already have the image, I'm going to remove this lah. Okay, so we start with this. Okay, so we know whenever we do this, we have to split it into 2 answers, okay, as we have previously done. So we open the modulus, 6 minus 2x equals to x, and the other one is 6 minus 2x equals to negative x. One positive, one negative. So let me move the x over here. 6 equals to 3x. Okay, x will give you 2. The other one will be 6 equals to x, and this should be our answer because negative x plus 2x is x lah. Okay, so x equals to 6. Okay, now why is this question so like apa ini? Kenapa senang pula ni soalan ni? Because I want to introduce to you this concept called gx equals to x. Okay, what it means is if we map this, our object is x, makan. Okay, and then our image becomes x. So, the object is the image. Okay, so when the object, okay, or when the objects map, okay, into the same image, means the object and the image is the same. Okay, we say this is what we call this the object maps onto itself. This is what it means. And we see this in question 5. Sorry, we see this under this one, maps to itself. Okay, so maps to itself is this, is this concept lah. This is what it means. X becomes X. Okay, so this is basically the point of this question to teach you this term which is called the object maps to itself. Kan berbalik kepada diri lah. Okay, our final question. So the function is given over here, fx equals to mx plus c. Then you're given two mappings. F2 will become 7, F4 will become -1. So if I map this, okay, let's map it. 2, and then here will be 7. So the object will be image here, and then F4 will be mapped to -1. Let's put it into this function. Okay, our object is 2. So F2 equals to m, and then we're going to put in the 2 plus c, and we know that the image is 7. Okay, and since we have the image, we don't need to put the function at the beginning lah. Okay, likewise, we're going to do the same thing with the 4. So m4 plus c equals to -1. Okay, so the first question is find the value of m and c. Okay, and you know from this, if you see this, you can see that actually it is a simultaneous equation. Okay, so I'm going to put this as equation 1, and this is equation 2. Okay, and I'm going to have equation 1 minus equation 2. Doesn't matter lah. Okay, because what will happen is c minus c will cut off. So 2m minus 4m. Okay, you have that 2m minus 4m, and then over here 7 minus -1. Okay, so this will give you -2m equals to 8, m equals to -4. Once you have the m equals to -4, substitute. Okay, substitute into any one. I'm going to use 1. So -4 times 2 plus c equals to 7. This is -8 plus c equals to 7. C equals to 50. Okay, it will be our answer lah. Okay, for this. Okay, question B, the image of 2 under F. The image of 2 is just object is 2 lah. But the object is 2 actually given already. Look, the answer here is 7. Okay, but let's just double check lah. Okay, since our c is 15, our m is -4, so our function is -4x plus 15. And our object now is 2. Okay, because the image of 2. Okay, so f2 equals to -4 times 2 plus 15. This will give you 7. Okay, which is okay, it's already there. Actually, you don't even need to calculate because if you map it, you can see already. Object is 2, the image is 7 because the function is f. Okay, what I'm more interested in is this final question, which is the value of x that is unchanged under the mapping of f. This is another way of saying, okay, the one maps to itself. Means the object, after you map it, it still becomes the object. The image is the object. This is what this means. The value of x that is unchanged under the mapping. So we want to find the value of x that will give us fx equals to x. Okay, so -4x plus 15 equals to x. And this is pretty simple maths. all this question is asking you is to understand what it means when you say, after you map unto itself, the value remains unchanged. The x is still x. So if we do this, okay, I'm going to move the x across. 15 equals to 5x, x equals to 3. Okay, this is simply what it means. Okay, so I hope this explanation helps you. So for our next class, we're going to move on to the next subtopic. Okay, so I hope that you can get all this written in your exercise book, so that we can move on to the next subtopic. Thanks, everybody.